This is sort of part 2 to the update on Tria, really. I felt like rebuilding the prototype in a very simple form, as I have these are some of the components for the bigger one, but I had enough components left over, well, I should do anyway, for building a mini one, a very simple one. This is very similar to the setup I had originally on this, which, if you watched the older video, the maiden voyage of Tria, it was this setup, but not quite as, well, cleaner than this in some ways and not in some others. So I have the Magician chassis, which had the issue of it flipped like this when it tried to go too quickly, but I've put all the weight mainly at the back on this one. It's kind of botched together a bit because I was in a hurry building it. Like the battery is held down at the back with masking tape and wires just wrapped around it. The Arduino Uno I've actually mounted on this time with these little like shafts to hold it up. I've stuck the prototype board on, which has the H-bridge and some of the H-bridge to run the DC motors. A single H-bridge can run 2 DC motors or a single stepper motor. As these are bipolar stepper motors, they can turn forwards and backwards. They require 4 wires. I'll probably go into detail about how these actually work at a later date, but for now, just looking at the original Tria. I've got, as shown earlier, this Magician chassis has these 2 DC motors mounted underneath and a rear caster wheel, which is a ball, which is helpful because it can turn on the spot pretty easily with the ball. And yes, I'm just using the Arduino Uno, which is now my spare Arduino, or for testing when I'm using the Mega for something else. And I have a fixed infrared range sensor inside, which I've now mounted on before. The entire robot was the other way round before, so that was the front before, but now that's the front. I like the curved edge being the front. It makes more sense if I'm going to have a panning sensor that it be on the front curve. This time though, as this is only fixed, before I did have a pan and tilt mount, which is this, with 2 servos, one mounted on top of the other, turn horizontally and vertically, and the sensor was mounted on top, and this was placed, which was kind of really dodgily mounted on here, which of course, as you can see, makes it rather tall and quite cumbersome really to control, and the extra weight made it topple. But yes, that's that. The only issue with this infrared sensor is this is the long range, if you can call infrared sensors long range. It can sense quite a bit over a meter in front of it, which is quite good if I was doing any form of environment mapping, which for this little prototype I'm not. But the issue with it can't see any closer than about 20 centimeters, which is a bit of a pain when it's dodging obstacles, as the sketch that I have on this Arduino at the moment for the demonstration that will follow this is just when an object gets too close, it'll pick a pseudo-random direction to turn, so either left or right. Because they're DC motors and I haven't got any sensors on it to detect how far it's turned, it's just going to turn for a arbitrary length of time, which I haven't played with too much on the current setup, so it's not that accurate. So it could just do this, or it could turn quite a lot. We shall see. The only issue with that is because of the range that this has, that it can't really detect here, that if it turns into an object, it'll think the object's not there and continue driving and collide into objects. That will probably happen a fair bit. And yeah, messy wiring, just prototyping really, just to get it going. Of course, this chassis, we can mount all sorts of things on here, more sensors, anything, but this is probably to the extent of what I'm going to have it at. I might have this this sensor here turning, as the reason it picks a random direction is because it can't tell which direction has more space to go in, because this is fixed. If I had it on a servo turning, or I had 2 sensors, or 3, 2 is good enough, it will be able to determine which direction had more room to turn into, if that's what we wanted to do. So I will move into a space that I can actually let this go without it trampling over my desk, and see it running. It probably won't run very well, as I did build it in about 5-10 minutes. But yeah, okay. Okay, here we go. This probably isn't the best place to do this, as there's stairs here, but there is a reasonable amount of room to test this. So I'll just point it down there. I wouldn't be surprised if this fails horribly and just crashes into things. And there it goes. Oh. And it's too close to the edge. It can't determine where the edge is. But you can see the wall, and that's going to drive down some stairs. Back in. Let it drive off again. Can it see the wall? Yes. And now it just drives into the wall, as the wall was too close when it turned. This is turning out to be quite a bad test, but you get the point. And it can see the wall and dodge it, and drive along the edge, and probably fall off. Let's point it a different direction. Saw the wall, but oh, I was going to say it got too close. Oh, yeah, it got caught. But that's very, very basic and not all that successful, but you got the point. With a bit of calibration and not having the battery falling out the back, but another sensor, or just the sensor being able to tilt slightly, it should be able to quite easily maneuver an environment and not bump into things. Probably having sensors on the edges might work better rather than directly on the front. But yeah, that's a very toy-like Tria.